Hey there YouTube, RD SWAT Team 19 here with a new video, and today's video is going to focus on how to complete a derivative. So differentiation in calculus 1 pretty much. So the first question we want to ask ourselves is, how do we approach this problem? Okay, so there are four types of derivatives. There's the power rule, the product rule, the quotient rule, and the chain rule. Okay, so today we're going to focus on all of these. I'm going to give you some examples, and we're going to work it through together. So feel free to pause the video, try the problem yourself, or just let me do the problem, and you can try it afterwards, see if you get the same result that I do. Okay? So the first rule in differentiation is the power rule. So the power rule is pretty much I guess the easiest one. Basically, you have your x term, right? And then let's say we have x squared, okay? So to do the power rule to this term, we're going to have to pretty much subtract the numerator by 1, and then bring this is pretty much, the 2 is pretty much your end term, so this will come down to as the coefficient of your x. So it'll be, so we're bringing the 2 down, which is going to become 2x, and then just subtract that numerator, the exponent by 1, okay? So in this case, 2 minus 1, which is 1, right? Just like that. So this, the f prime of x, which is our derivative, will equal to 2x in this case. We could write the 1, but in most cases we don't write the 1. So the derivative is 2x of x squared. So another one would be x cubed, right? Same thing, bring this term to the front. So we have 3x. And then we're going to subtract that, the exponent by 1, which will be 2. So 3x squared is the derivative of x cubed. So basically a way we can write this as sort of the rule of the power rule is f prime of x, which is equal to y prime, right? F prime of x, the derivative, is equal to x to the n minus 1 and the n in the coefficient. Okay, so this is sort of the key rule to know when doing the power rule in all derivatives. So let's do an example. So we have 4x cubed, okay? So we're going to start off by writing y prime equals, and again, feel free to pause the video, try it yourself. So we have 4x cubed. So pretty much we're going to bring this 3 down to the front. So 4 times 3. So I forgot to say on the top here, we're pretty much multiply the exponent by the coefficient, whatever's down here. So in this case, we brought the 3 down, which is 3x squared, right? But in this case, we have a 4 in the front. That's our coefficient. So we're going to bring a 3 to the front, right? So we have 3 times 4x, and then the 3 is going to subtract by 1, right? Always the exponent, which is going to be 2. So we're going to multiply these two. 3 times 4 is 12. So the coefficient is going to be 12. We keep the x, and then we subtract our exponent by 1, which will give us 2. So in this case, the derivative of 4x cubed is 12x squared. Okay? All right, here we go. So whenever we have a derivative, it's the same process. In this case, we have a coefficient at the end, right? It doesn't have an x, it doesn't have any other exponent or anything, it's just a solid. So whenever you have a coefficient just like that, it's going to be 0. Okay, automatically we'll just cancel out. So we have, in this case, f prime of x is equal to, same process, we bring this down. We have 6x, subtract the 6 by 1, and that becomes 5. We're going to plus this, Put this in black ink. Bring this 3 to the front. 3x subtract the 3 exponent by 1, which is 3x squared. We add, same again, 2x subtract the exponent by 1 is 1, plus, alright, so whenever we have an x or any variable, just when you see it like that, the derivative is going to be what's in front. So in this case, it's just 1, right? There's an invisible coefficient of 1 in the beginning, right? And then there's no exponent on the top, so the derivative is just going to be 1 plus, as I said before, any coefficient that's just there, it's a constant, right? Cancels out, that's 0. So we don't even have to write this. So this is our derivative. Right? So it's pretty self-explanatory. You just take you bring whatever's in the exponent, bring it to the front, multiply it by, the x that's there in this case, right? But if you do have a coefficient like we had over here, multiply that exponent by that coefficient, which will, in this case, gave you 12, and then you just subtract that exponent, the original exponent, by 1. Okay? So the next rule in differentiation is the product rule. So in this case, let me just give you a quick example. Let's say we have 8x squared. Let's just make it 8x. 8x by 6. Let's make it x squared, actually. Yeah. Okay. So the product rule is different because we're not in the product rule. You never do the power rule on both of them and just like add or multiply them. That doesn't work like that. Pretty much you're gonna keep one term. So you're gonna keep, so this is gonna be our u and this is our v term. Okay, so we're gonna keep the u. Actually, so we have u and u prime, the derivative of this u term, the v and the v prime. Right? So our u term is going to be our 8x, and our v term is our 6x squared. Now, the prime obviously is the derivative, so the derivative of 8x is what? 8. And our derivative of 6x squared is 12x. So once we have those, then in order to apply it to the product rule, we have to, a rule for the product rule is pretty much u, okay, the way I remember this is keep the first, derive the second, plus keep the second, derive the first. Okay, so again, we're just gonna plug in. So we have our u is 8x, v prime, which is our 12x, plus our v, which is 6x squared, multiplied by our u prime, which is 8. Some teachers might say you can just leave your answer just like this, but in this case, let's see, f prime of x equals Can we come out of this? I don't think so. Well, to not make any mistakes like I might do, just keep it just like this, combine it in these u v prime plus vu prime term, and this is teachers will most likely accept this answer. I just didn't want to make a mistake like I usually do on tests. So, you don't want to make those little silly mistakes. So just check with your teacher if you can just put it just like this, and you should be just fine. So here's an example. This one here is our u term, and here's our v. Right? So we have to know that we have to do u v prime plus oops, I mixed this up. U prime, let's put this over here. Let's see, right? So we have keep the first, derive the second, plus keep the second, derive the first, right? So this is going to be our the key idea for solving these. I'll just put this, highlight this. All right, so we're going to write our terms on the side. Let's color code this. U prime, V prime. All right, so our u is x plus 2. Our v is x squared plus 5. All right, so the derivative of x plus 2 is going to be 1, right? The coefficient of x, which is the 1, and 2 is the constant, so that would just cancel out, so that's nothing. So it's 1. And the derivative of x squared plus 5 is going to be 2x. And the 5 is a constant, so that cancels out, so it's just 2x. So now we plug everything in. So we have our u, which is x plus 2, multiplied by our 2x, plus v, which is x squared plus 5, and our u prime, which is 1. Let's make this. So you can leave your answer just like this, but I'm going to try to combine this. So f prime of x, I'm going to distribute. Two x squared plus 4x plus 5, and then we can combine these. So we get f prime of x equals 2x to the 4th plus 4x plus 5. Right? If you don't want to make a mistake, again, just leave it in this term right up here. Okay? So this also is an answer. Okay? All right. Next example. All right. So now we have a cos in our original y function. So again, I can write invisible parentheses here, and it's the same process. Okay? So now we are going to write our formula, which is keep the first, derive the second, plus keep the second, derive the first. Now we're going to use these on the side. Our u is going to be this one, v. So put this in, let's do a pink. Right, so we have 4x, and we have cos of 8x. the derivative of 4x is our coefficient of 4, and our derivative of cos 8x. All right, so this derivative includes the next rule, which I will mention in a few minutes, the chain rule. Actually, in a few rules after, the chain rule. So the derivative of cos is going to be negative sine. We keep our g of x function in the inside, which is 8 of x. And then take the derivative of the inside. So the derivative of 8x is our coefficient of 8. And to rewrite it, we get negative. We bring the 8 to the front. So we'll bring this guy up here. And then we have negative 8 sine 8x. Okay? So then we're going to plug everything in. So we have our u function. So let's write here f prime of x equals. We have our u, which is 4x times, I'll put this in pink, our v prime, which is our negative 8 sine 8x. You can also leave the 8 on the side over here, but I just rearranged it so that negative 8 is the coefficient, which is probably the easiest way. And then we're going to add this. Let's bring this guy actually down here so we get some space. Sorry, this is like a little sloppy. Let's shrink this down. All right. Okay, so plus we have our v. Oh, I didn't put the second prime in pink. Cos 8x, our original v, and then we multiply that, let's put this in parentheses, by our u prime, which is 4. All right, here it is. Here it is our derivative. Just write it like that in this form, and you're good. All right. The next rule is the quotient rule. So this rule is pretty much sort of similar to the product rule, except our u v prime plus vu prime is going to be arranged differently. So in this case, on the product rule, we had our u and we had our v. So in the same process, we're going to have our f of x equals something over something, where this numerator is going to be our u and this denominator is going to be our v. Okay? So the rule is, for the quotient rule, is going to be, let's put a nice color here, orange. All right. So the rule is going to be our v u prime, let's see, okay, here it is. So the rule is going to be our v multiplied by our u prime minus our, that's a u actually, if you guys can understand that, u, whoop, this got messed up, well, let's correct that, minus u times our v prime. Man, u and v always gets me confused. All right, so, and over our denominator, which was v squared. So if that's a little hard for memorizing that, what I was just thinking in my head is low d high minus high d low over low squared. This is what my calculus 1 teacher in senior year of high school taught me. So the low, which is our v, multiplied by our dh, which is the derivative of the high, which is u prime, minus, because of the quotient we're going to subtract, the high, which is the original, what just happened? Our u multiplied by the derivative of the denominator, which is v prime, over all that divided by this squared, the v. That's what this is. Okay? So this is going to be our general rule for the quotient rule. Okay? So here it is. We have y equals 2x plus 7 divided by x squared plus 4. So we're going to write our rule on the side. We have low d high minus high d low over low squared. So we're going to start off by writing, let's do actually y prime equals. All right, so we have our u and we have our v. So let's write these on the sides. Let's write it over here. We have u prime, v prime. All right. Our u is 2x plus 7, and our v is x squared plus 4. Again, feel free to pause the video, try to do the derivatives by yourself, and then you can just hit play, and then you'll see how we can do it. So our derivative for u is going to be 2, just that coefficient, and the 7 is a constant, so that cancels out. The derivative of v is going to be, we bring that 2 down, so it's going to be the exponent of 2. So it's going to be 2x, and then the 4 is just a constant, so that goes away. So we have u prime is 2, and v prime is 2x. So we're going to apply our formula, and we get our low, which is our v. So our low is going to be x squared multiplied by our the derivative of the high, which is u prime, which is just 2, minus our original u, the high, which is, what are these colors? 2x plus 7 multiplied by the derivative of the denominator, which is 2x. All of that over our low squared, which is x squared plus 4 squared. Alright, so let's add another page here so I get more space. Okay, so let's multiply everything out and expand the numerator. Your professor will probably say you can most likely leave it in this term, just like this. But let's try to expand it out a little bit. So we have y prime equals, we're going to distribute the 2 with the x squared plus 4. So we get 2x squared plus 4 times 2 is 8 minus, again, the 2x, which is 2 times 2 is 4x squared, because x times x is x squared. 4x squared plus 7 times 2 is 14, and then the x, over all right, so we have y prime equals, let's see, so 2 minus 4 is going to be negative 2 x squared. Let's actually put this in a different color. y prime equals negative 2 x squared by subtracting the 2 and the 4. And then we're just going to plus 14x plus 8 over x squared plus 4 x squared plus 4. So now, I'm going to say leave it like this. I feel like I'm missing something. Feel free to comment below again if you think there's another way. But you can also leave it in this term. I think I did this right. I feel like something with a denominator. I actually have this file on my iPad from my the exam. So let's see. Fall semester. Here it is. Okay, so in this case, right, so in this case, the numerator we got was pretty much right, but in this case on my exam, I left the denominator original. So I can expand it out, but let's leave it just how I did it here. So let's reverse this and reverse this. So we get, whoops. Right? So again, both of these are correct answers. Just this one, I just simplified it more to a more reasonable answer. Okay. All right. The next one that I mentioned before is going to be the chain rule. The chain rule you're going to use a lot with the trig functions. So with the chain rule, you're going to have your f prime g of x multiplied by the derivative of the inside, which is the g of x. It gives you the g prime of x. Okay, so as I said before, was it negative cos I did? Yeah, cos 8x. Okay, so, whoa. Alright, so I had cos 8x. Right? So the first thing for this part is taking the derivative of this cos, which will give you a negative sine of x, right? But now in our x inside, we are going to put in the 8x. And then with the chain rule, as it mentions right here, we have to take the derivative of the inside function, which is our 8 of x, and the derivative of 8x is 8. So this is correct. Or I can bring this 8 to the front, which will be my coefficient. That's sloppy arrow. And I get negative 8 sine 8x. Right? So here's another example. We have the derivative of sine. The derivative of sine is not negative cos, it's cos, positive cos. So f prime of x equals cos we keep our inside function, we bring that down, so we have 3x squared plus x, and then we have to multiply the inside, the function. So we're going to multiply by the derivative of the inside, which is 6x plus, this has an invisible 1, so this is our derivative. We can also bring this 6x plus 1 to the front. So we would also have 6x plus 1 cos 3x squared plus x equals our f prime of x. Alright guys, thanks so much for watching this video. Please hit that like button, subscribe to my channel on YouTube at rdswatteam19, and also you guys can follow me on Instagram at TheRichPatino. And please subscribe to my channel, hit that like button, ask me any questions, and thanks so much for watching guys.